Hello guys, welcome back to the Azure Guy, and we discussed in the part one about how exactly we gonna uh, provision a multi-tenant architecture for each of the customers on your single AKS cluster or Kubernetes cluster. Okay, irrespective of whether you're gonna provision this on Azure or the GCP or AWS, it's gonna be the same. If you go ahead and as I said, I have you can go to the Azure Guy 007 and you can go to this particular repository or the project which I am so you can see this particular project which is about Kubernetes AKS multi-tenant implementations, and where you have as stepwise like you need to create service principal and client principal ID, and you need to spin up your cluster, an RBAC cluster. You need to prepare your YAMLs for each of the tenants. Basically, they will have a role and the role binding, and you need to define those add-on email YAMLs like the resource quota, limit range, network policies, each and everything. Which will have the Calico as well, and then you can have a DevOps integration of deploying your applications into provisioned a Kubernetes cluster. For that, you have already mentioned in the repository. If you go to the repository, you will have a brief links which actually would point on how to integrate with DevOps and how to create one with the service principals and the client service principals mentioned in the Microsoft doc, which I've mentioned in here, and I've used the same. And let's go. So this is particular YAML. Let me duplicate it and then let's go into it. So this is my multi-tenant Kubernetes, and then so the main challenge when you implement your Kubernetes RBAC Kubernetes cluster is like the Kubernetes default dashboard is not available for everyone, because again you need to have certain rules and role bindings. You need to define certain role and role bindings so that you will have a dashboard reader access. You can give a dashboard reader access to your authenticated users who gonna get authenticated from AAD, right? So for that only you have something called as Kubernetes dashboard access. If you want to spin your RBAC cluster and you just want to give access to read the Kubernetes default dashboard, and this is a place where you need to look in. So you can see this is a dashboard reader. This is a dashboard reader role binding, but before defining a role binding we always need to define a reader role. So these are sort of YAMLs which you can directly copy, and what it does is like it would give you access to the Kubernetes dashboard pod, and then it would give an access to the proxy, so that you can actually use a proxy to get connected to your Kubernetes dashboard. So basically it would create a dashboard reader role in your kube system. So these are not by default created by Kubernetes when you define it as you create a RBAC Kubernetes cluster. So but you need to explicitly define them as of now. And once you define reader role, you need to bind that particular reader role to any of your Azure Active Directory group. So what exactly is here happening is like when you want to onboard any particular teams onto your Azure Kubernetes service, or you want to give access, the best way is to create an IAM group or create an Azure Active Directory group, so that you can manage your users there who want to access or who are there in the project and who can access your cluster. So that's an easy way, because you don't want to have another identity source system inside your Kubernetes to manage it. Okay, so rather you can manage that particular identity by taking an advantage of Azure Active Directory. You manage this in a security group, or an AD group, and then you give that particular AD group object ID in here, and then you, as you created a reader role, so you map a role reference with the dashboard reader role, and then these are particular API which you're gonna use, and you're gonna define this particular reader role binding in your kube system. So this the RBAC reader role, everything need to be mentioned in the kube system. You can't mention in your own namespace because it's gonna be constant to everyone. Okay, so because whenever an unauthorized and anonymous user comes and after he authenticates with AD, he would be redirected to, and he would be given by default this particular reader bindings and reader role permission so that he can go and access it. Yes, obviously you need to mention this particular AD group, then only they will be having an access. If you want to mention a specific email ID or a specific user, then you can, in subjects, you can make this particular kind as an user and give the email ID. But remember that that particular email ID need to be in uppercase. Especially the user name should be in uppercase letters. So that is one thing. So where how we talked about how you would give just an access to dashboard. Okay, and then you would be interested in creating the namespaces for your customer, right? So these are the namespaces which we can create dynamically using YAMLs. Okay, and the best benefit of using YAMLs is like you can use these YAMLs again instead of running manually. You can actually use it in your Azure DevOps, and then you just kick off this particular scripts. So you can automate and you can set up your own fault recovery. What I can say is like uh, disaster recovery situations, you can use this particular scripts to spin back your particular cluster, complete cluster and namespaces together, your multi-tenant cluster and namespaces within few minutes. And let's take an example of just one particular single tenant. Okay, so you can use a namespace conventions like I've used application name, their particular billing plan, their environment, their particular service component, like that. And we basically define a namespace. We will be creating a namespace, and the namespace can have label because it would be easy it would be easy to distinguish any namespaces. And also you can set up kubecast or other particular monitors on top, and you can actually use labels to categorize or filter your particular metrics. Okay, so for that you would be requiring the labels, and it's easy to distinguish as well, to keep up monitoring and usage. And you have something called as resource quota, which you need to define on this particular namespace. When you create a namespace, you define a resource quota. That's which I was talking about, the resource quota and the limits. Okay, so as we said in the part one, like we will be using resource quota and limits, and they basically concentrate on an entities like CPU and memory. Okay, so if you go here, then you can see that it is defined on your namespace. Like you can say your own namespace, and you can actually limit the pods, but as of now we can comment it. But in your case, you can uncomment and use if you want to restrict number of pods which you want to create, or limit your user or you play application user or your customers to be able to create. Because if you have a limitation of using Azure CLI, where you can actually only allow few limits of IP addresses, limitations of IP addresses, then you can actually go with the number of pods which you can define for the fair usage. And you can define something called request.cpu. So the number of requests which gonna come to your particular namespace can only be across two, which can occupy at can only reach a max of 2 2 millicore. And request or memory can reach up to 8 gigs of memory. The amount of data which can be written, or which would be as a part of ingress or egress, can only be limited to coming out of the namespace, or writing onto the persistent volume can only be limited to 8 gigs of memory. So these are the default figures which I have defined for my use case, but you can define for yourself. And also you can set the limits. So the request.cpu and the limits.cpu can be same, or the .memory can be same, or they can vary based upon the use cases. So I would set my limit.cpu as 2, and then 8 gigs of memory they can claim. Or so this is a respect of number of they can run a single pod which can be using the 2 millicore of CPU or 8 gigs of memory, or they can run like sort of 2 pods which can be using 4 gigs of memory and 1 millicore CPU RAM. And then we can, after you define the resource quotas on your namespaces, you can also define something called as, you can create your own role, like namespace admin role you can create for your namespace. Since the roles that namespace admin would be specific to your namespace, so that's why you'll be giving your namespace, and you can tag it as namespace admin r or a namespace admin role. Okay, and these are set of actions which actually I've defined in my Kubernetes sessions as well. I will be providing the link to that so that you can understand what exactly role and rollback, and role will have sort of CRUD operations on each and every APIs which a particular role can access. Okay, so here it says like you can get roles, a list of rows, get rows, list rows, watch rows, create and update and delete rows. Okay, so being a namespace admin, you can actually do this, all these particular activities in your namespaces. Similarly, for role bindings, you can do services, endpoints, pods, pod logs, pods attached, nodes. Nodes is just a get list watch, because nodes need to be under the control of your cluster admin and not the namespace admin. Okay, so these are the sort of cases or scenarios where you would consider whether you're going to give access to a particular namespace admin or not. And there are a lot of services: config maps, batches, daemon sets, replica sets, replica controls, persistent volumes, persistent volume claims, limit ranges, network policies, and each and everything you actually need to define. So I've since this particular APIs list, it came through a lot of extensive research and in like which I've done for my use case, but you're getting ready to eat. Okay, so I hope if you like my efforts, you can always subscribe to my channel and click the bell icons to get this sort of latest implementations on cloud. And once you define the role, and then you can also define role bindings, and in the role bindings you can, obviously it would be specific to namespace, and as I said, you can put your subject as a kind user or a group, and then you'll be defining it. So that is one thing which we have talked about the namespace, and with very specific to namespace. And then on top of that, we talked about resource quotas and limit range, right? We can actually limit set the limit range, or set default limit what a person can use, or what particular, like if you can see here, we have a default limits, right? So you can set the default limits using the YAML, like how much they can use, like implicitly. But what we can do is like we can also explicitly define them. So in this cases, we have defined like the limits will be the default limits. We can define it as 200 M. So each of the pods which they're gonna run, it would be allocated at 200 M, because in many cases, like customers may just run a Helm chart, and then they may take a default values which are provided by the Helm or any particular vendors which they are using. For example, if you're using an Nginx Helm, and your particular Nginx pod which is running in this particular like namespaces can actually consume more than what you want to specify. So for those sort of requests where you are explicitly running your pods from a Helm charts or some other repository, you actually can define a default limits. Okay, so the default limits you can also mention during the creation, where if you have kubectl apply -f your YAML, if you're providing, you can actually give something called as a limit, a default range, a default CPU you can give, default memory you can give, and max this particular pod which it can reach, and minimum which you want to allocate to this particular container, you can mention it here. Okay, so this is a way of providing a default values in case users forget or customers forget to give. This is a good way of setting up the limit range. And if you want to know about more about limit ranges, obviously you can Google out and let me know your questions. If you have more doubt on the limit range, you can just tweet me at the rate the Azure guy 007. And the similarly, like if you want to create you're gonna be an namespace admin. So if you are a namespace admin, and if you want to because as a namespace admin you can actually create users for your particular namespace, right? So you can use this particular YAML to create a custom user for yourself. Obviously user you can create a role and role binding, so it would be very similar. So role, you will have a set of actions, verbs, API resource groups, resources what you want to access, and you will have a role bindings. Okay, so you can access them here. It's sort of a complete set of resources you to set up the complete multi-tenant architecture in your own organization. So let's go and talk about the network policies. As I said, the network policies are very important in cases where you want to isolate one particular namespace from the other particular namespaces. Like you don't want pods in this particular namespaces going and talking to the pods in this particular namespaces. But by default, what happens is, like when you provision a cluster with multiple namespaces, they have a default access to the all of the namespaces. The pods in this particular namespace can talk to the pods in and other namespaces. Okay, so that is one particular disadvantages. But yeah, you don't want to restrict until unless you want to restrict. What you can do is, like, okay, take an example, like if you want to communicate from this particular pod in here to the pod in here. So it's very simple. You go log into this particular pod. So so for logging into that particular box, what you can use some concept called as virtual box. You can run a virtual box pod using which you can actually log into a particular pod, and then you can run a curl command. What you can do is, like, you can do a curl, and then you can mention the namespace 1 dot app 1. Okay, and then like when you do the curl, it will actually try to curl and make a request from your particular pod to the pod which is sitting in the another namespace. So this is one way of one particular mechanism which is called as cross namespace communication in Kubernetes. You actually can according to your use cases, like if you have applications owner, a single owner, namespace owner, who want to deploy applications into different namespaces, but he want to set up that particular cross namespace communication. Yes, you are open to use it. Since by default it is allowed, but you don't want other particular namespaces, like three or namespaces, and to communicate to both of this particular cluster, then this is a particular way to go. So when you want to like deny the other namespaces, all the namespaces, then you can just go use a concept called as pod selector. You would be blocking all the pod selectors, and you won't be allowing any egress from this particular namespace to here, or any ingress from here to here, or any other particular namespaces. So this is particular policy which you can use in all namespace network policies, which can be applied on the pod selector, and even you can use something called as namespace selector to apply it more on the namespaces. So this one would block on the pods, but yeah, you can apply on the namespaces. And if you want to allow a specific namespace to talk to your particular namespace, then you can use this particular YAML where you need to mention since where exactly you will run. So if you want to apply your network policy, basically you need to you can use Calico or default Azure network policy as well. And this one remembrance, what you can do is, like when you create a cluster, you need to mention your network plugin as the earlier, and the network policy as a prerequisite, because you can't change after you create your cluster. Okay, and I'll be showing how to create a cluster. That's a simple way. And so once you have your network policy defined as a Calico, you can use this particular policy. And so wherever you want to define, you need to mention that particular namespace, and from which particular namespace you want to open the communication, you need to mention in here, and you would be allowing those particular pod selectors, and you would be giving the egress and ingress access to that particular specific namespace. Okay, so and if you go back let me rectify. If you come here, you didn't have a mention of any namespaces, so it won't allow a communication from other namespaces, from this space to this namespace to this namespace or this namespace, but it would allow pods from within the namespaces. So for that, you can have this, you can see pod selector is null, is like you will allow everything. But since you didn't mention the namespace selector, so it would just concentrate or give access to all the pods in this particular namespace to communicate with each other, but not with the other namespaces. So this is one way of setting up your network policies. If you have any doubt, please tweet to the the issue guy 007. Pod security policies I would be defining you later, and there is easy way of yes. Another thing is like. So when you spin up a ingress control, when you spin up your AKS cluster, so by default, AKS cluster would spin up a external public IP. But when you work on enterprise, it won't be, you wouldn't, you don't want to allow public IPs to get created on your subscriptions. So what you can do is like you can use something called as user-defined route for this. Using user-defined routes, it would actually block for you from creating a public IPs. Instead, it would create an Azure internal load balancer, uh, uh, internal load balancer, and internal load balancer it would create. And how it would be created, like you can say this particular code where you have something called as yes, here it's called as you need to mention as outbound type is equal to user defined routing. So this is one particular parameter which would block you from creating the internal IPs in your particular MC underscore resource group. MC underscore resource group is nothing but the dependent resource group or the secondary resource group which would be spun by your Azure Kubernetes services or your Kubernetes services. Okay, so the MC underscore resource group would have the secondary resources like your particular VM scale set, if you're using a VM scale set, or your Tuscal group, or your virtual nodes, or your nodes, or in fact your storage, everything would be sitting in your secondary resource group. But the resource group which you mentioned in creating your cluster would be would be having only the cluster which you define with the name. So this is one particular the AKS cluster. It's a CLI where you can use this particular thing. And network plugin, as I said, you can choose between Azure CLI and Kubernetes. And network policy, you need to define it earlier, because you can't create post. You can't change after post creation. You can choose between network policies, Calico, or default. And you can generate SSS key. And when using an UDR or user defined route, the service here, the CIDR and the DNS service Docker bridge address are very compulsory. Okay, so this particular portion are compulsory and they are static with respect to your network. And then you have something called as VNet subnet ID. You need to give the full path of your subnet ID. And as I said, you need to create a client app ID, and you need to create a server app ID. You need to give the GID or the object ID of them. And you also need to give the same service principal, mentioning as a service principal. This is for few of the activities you'll come to know, and the client secret, and then also the AD app secret. Okay, and then you would give your directory ID. And then if you want to attach your Azure Container Registry by default, then you need to give the whole path of your Azure Registry. And then you have monitoring you want to enable, Azure Health Monitoring. Then you can use this particular enable add-ons monitoring. And then auto scale, if you want to give, then you need to enable auto scaler. And then you need to define the minimum count and the maximum count. And this is a main parameter where you will enable RBAC. Okay, and then you have something called as the node VM size, where you will define the size of your node. So you can go and check, try to create the resource manually, and you can choose the resources size which fits for your particular use case. I've taken DS to V2 as one particular example. You can set the VM set type as a virtual machine scale set, so that you can take benefit of auto scale. And then you can mention load balancer SQL standard and outbound type as user-defined, as I said. And then in order to safeguard your Kubernetes API server from DDoS attacks, you can actually mention something called as API server authorized IP ranges, and you can give your the shader range, your IP's range or shader range. You can mention your Azure DevOps, all of the services which will be having access to or need to access this particular AKS cluster and this particular API server authorized IP ranges. And then once you have cluster on, you can use Azure AKS get credentials with this particular process, or you can browse your particular resource group, and basically it would browse your particular dashboard, and you can take the detail of your cluster by using Azure AKS show. Okay, so this is one thing, like where you have complete cluster everything. And then like once your cluster is up, you may be interested in running your particular sample application. So sample applications with all the quotas and everything, resource quotas implemented on your container. So I have defined everything. I've done for you a job for you, so you can just go and use it, modify according to your need, and then go ahead. If you like it, put a comment. If you don't like it, then also put a comment so that I can improve myself. And this is a one case where you want to define your own particular internal app or load balancer you want to run. Then you can run this way, which would create an internal load balancer for you. And then if I go out, then yes, you can define your own ingress and ingress YAML. If you want to define, so why exactly, so we have an ingress controller defined, right? So you can tag an ingress controller with a load balancer IP, as I said in the part 1, and then you can actually define ingress specific to your namespaces. Okay, so you can define ingresses in two ways, like you can define define ingress for HTTP traffic, or you can define the ingress for your HTTPS traffic as well. Okay, so there would be a lot of confusion, like when you define a HTTPS, you would just see an HTTP attribute here. So there's no confusion because you will be mentioning a TLS cert. So the TLS cert is nothing but if you take an example, if we go back to this particular one, it's calling HTTPS app1.domain.com. Okay, so when it's calling over HTTPS, obviously when it comes all the way, it would expect, your engines would expect a certificate to be presented. Basically the HTTPS or certificate would be having the public key, and that public key can only be decrypted using a private key. So the private key would be, you are responsible to provide that particular private key, and for your integrations you actually can keep that particular private key in Azure Key Vault, and then you can use them using the managed service identity, where you can give access to your secrets, the secrets which would be sitting on your Azure Key Vault safely, and you can add them as a part of the TS secrets. There's another way of automating, is like you can use Azure DevOps, and you can use a concept of library, and where you can have where you can define your particular Azure Key Vault secrets in there, and then use them in your own pipeline, and then push your secrets from your Azure Key Vault directly into your namespace. So ultimately that particular secrets will go and end up in stored in under Nginx ingress controller access. Okay, so once you have the private key available as TLS secrets, then whenever the request comes with a certificate, it will actually use this particular private key to get it to decrypt the public key in the certificate, and then it would SSL offload your particular HTTPS call, and then it would traverse your communication as HTTP back to all of your namespaces. So you can have complete secure access till here, till your Nginx controller, and from there after the SSL offloading, you can actually route your HTTP traffic to any of your applications. And similarly, when it goes back, it would pick up the key, and then it would go, the request would be, once that SSL connection has been set up. So once the request comes and the request ends, SSL termination can easily happen in here, and then your complete access would be secured. So that's what is that I'm talking about, the TLS secret in here, where you will mention your public IP, and that would be part of a secret inside your Kubernetes, and you need to mention your host. So you can mention app1.domain.com in here in as a host. So what happens is, like, when you do that for app1.domain.com, so you will be making an entry in the your public DNS, or you can make it an entry in your internal DNS, so that your applications who want to use a service which are running under the cluster safely underneath your particular enterprise, the enterprise architecture, enterprise network, then you actually have a private DNS, and you have the host entry as a part of the private DNS entry, and then this host IP would be mapped to the internal load balancer IP, so that even the traffic which is coming from outside world over the internet or from your internet all can map together, or finally end up in your internal load balancer. And since the internal load balancer has a good mapping with Nginx, so when the request comes to Nginx, it will actually, the Nginx know each and every stats of your particular services which are running, and it can redirect your traffic to there. So this is one thing. So you can go inside this particular file, and you can define like how much amount of traffic or packets you want to allow, and you can use this particular health checks. So when you set up ingress, so the first thing, like the good thing to check is, like, you can actually try to access, once you install your Nginx controller, you can try to access your Nginx controller over the IPs. Then it would present you health check or the default page, so which would also ensure like you have installed your Nginx successfully and you are getting rerouted till here. Okay, so that's one thing for which you can always enable health checks, or anywhere you have a default pages as well, right? And this is what is completely about this particular project. If you like it, you can fork it, and please add your comments and let me know whether it was a good learning for you or not. With this, I'll end up this call, and have a great day. Happy implementing on implementations on cloud, and happy AKSing or Kubernetes.